Very good afternoon. We will try to solve 5 questions today also, like every day. So, first question, let us go through. A projectile is thrown with an initial speed u at an angle theta above the horizontal, neglecting a resistance. Which statement about its motion is correct? First option, acceleration is always vertically downwards and constant in magnitude. This is correct. Resultant acceleration becomes zero at the highest point. Okay, this is not correct. See, in projectile motion, okay, this is the point of projection. If an object is thrown with an angle theta, okay, at the highest point, only vertical component of velocity becomes zero. The horizontal component will still remain. Okay, and this is ux, this is uy. After a time t, vx will remain ux. The horizontal component will not change, whereas vertical component will go on changing as per ux minus gt. At the highest point, v, the vertical component of velocity is zero, horizontal component remains. So resultant acceleration becomes zero. This is wrong. Horizontal component of velocity keeps decreasing. No, the horizontal component of velocity at any point, this Vx will always remain Ux. Horizontal component will not change because there is no acceleration in the horizontal component. Acceleration is there only in this vertical direction, that is G. Okay. So C is also wrong. Vertical component of velocity remains constant throughout the motion. No, vertical component will change as per this equation. Vy is equal to ux minus uy minus gt. Sorry, this is uy minus gt. So only first option is correct. Okay, we'll see the next question. It is a graphical question from kinematics. Okay, xt graph in a displacement time graph for a body moving along a straight line. A straight line with a negative slope indicates. Okay, looks like a very simple question. Negative slope. Okay, at rest, moving with constant speed in the positive direction, accelerating in the positive direction, moving with constant speed in the negative direction. So the graph is something like this. It's very familiar xt graph, something like this. So this is a line with negative slope, a straight line with a negative slope. Okay, see on an xt graph, slope is equal to velocity. Slope on the xt graph represents velocity. If it is a positive slope, then it is a uniform velocity, positive velocity. Now, if it is a negative slope, that means the body is moving with constant speed in the negative direction. So this should be the correct option. Okay, third question, Nodona. We'll try to see solve this. Again, a conceptual question. In a series LCR circuit, add resonance. Which of the following statements is true? Power factor is zero because net reactance is not cancelled. Impedance is maximum, current is minimum. Reactance is maximum, voltage leads current by 90, impedance equals resistance, and current is maximum. Okay. What happens at resonance? Inductive reactance becomes equal to capacitive reactance. So impedance is equal to R. Impedance is equal to R. Okay. So this is actually minimum impedance. Impedance is minimum, so this is wrong. Impedance is minimum, so therefore current is maximum. So this option will go. Next, power factor. See, power factor is R by Z, and Z is equal to R. So this becomes 1. So power factor is maximum. So this is also wrong. Reactance is maximum and voltage leads current. No, this cannot happen because both the reactances are equal. Okay. So the only thing which remains, impedance equals resistance, current is maximum. So this is the correct option, D. Okay, another question based on concept. For an ideal gas undergoing an isothermal expansion, which statement is correct? Okay. Internal energy decreases, increases, constant, increases first, then decreases. See, for an ideal gas, internal energy, it depends only on temperature. Internal energy is a function of temperature only for an ideal gas. Okay. And for an isothermal process, Temperature is constant. So if temperature is not changing, that means internal energy, which is a state function, which depends only on the temperature, should remain constant. So that is option number C. Okay, we'll see the fifth question. It is based on system of particles, rotational motion. Again, slightly conceptual question. Solid sphere and hollow sphere of same mass and radius roll down an inclined plane without slipping. Which reaches the bottom first? Okay, solid, hollow, both together. See, when they are rolling down an inclined plane, so it is without slipping. That means it is a pure rolling motion. Okay. Now here, the moment of inertia of the solid sphere about the diameter, it is 2 by 5 mr square, and for the hollow sphere it is 2 by 3 mr square. So moment of inertia of hollow sphere is more than the moment of inertia of solid sphere. So this solid sphere will roll down faster. Acceleration of solid sphere will be more because its moment of inertia is less. So solid sphere should reach the bottom first. Moment of inertia is more. That means resistance to rotational motion is more. So this hollow sphere offers more resistance to rolling motion as compared to the solid sphere. Therefore, solid sphere will reach first.